I will tell you what the theorem is in a minute. It has something to do with how all of the sides of this triangle relate to each other. I'm going to show you what the result is, but I want to show you how I get the result. Okay, so all of this that I'm about to do on the board, you will have your time to draw. I actually have like a little guide for you that I'm going to put up on the screen in a minute. But for now, I just want you to be fully engaged with your eyes on what's happening here. Okay? So here's what I'm going to do. This theorem, this property, this result, relates these three sides together. So I'm just going to give them some names. Do you remember in algebra, we gave numbers names when we didn't know what they were? What was the point of doing that? Why is that useful? Yeah, Tarun.
Just in case you wanted to write the name of the angle?
Yeah, like an angle or a side or any kind of unknown value. I'm going to give these guys names A, B, and C. Not very original, I know, but at least that way it won't be hard to remember them. Okay. Now, A, B, and C, they're the three sides of this triangle. And what I'm going to do is I'm going to put a few more copies of this same triangle up on the board so that I can make a bit of a construction, a bit of a shape. Okay. So all of these triangles are the same. I've got 4 of them. Okay. So I'm going to arrange them in a particular way that I want you to notice. So I'm going to put this one over here. Good. Okay. I've got 2 more copies that are identical. Matthew, can you just, sorry, Tom, can you stick that securely on the back for me? I'm going to put this one and spin around a little bit, like that. Okay, and the last one? Thank you. Okay, wonderful. Perfect. Okay, now, I want you to look closely at the shape that I just made. By putting these 4 triangles together, I've actually made 2 new shapes. Can you see both of them there? There's one that's big all the way around. What kind of shape is that?
Square.
It's a square. Now just pause for a moment. Don't answer yet, just think about it. Apart from the fact that it looks like a square, how do you know that it's a square? Think for a moment, think. Charlie, I saw your hand up got pretty quick. Why do you think this is a square?
It's got 4 sides.
Okay, number 1, the first requirement for a square, it's got to be a quadrilateral, so tick, all right? Nikhil, give me something else.
Equal sides?
Now, what makes a square
Wait.
is that the 4 sides have to be equal, right? Now, hold on a second. How did you know that the 4, I mean, I know they look equal, but how did you know that they were equal? Daniel, what do you think?
The right angle on one of the shapes. Yeah.
This one here?
Yeah.
Okay. Now, you remember I said all 4 of these triangles are the same, yeah? So I've got a right angle here, which means I've got one here, and here, and here. Those are important, but they still don't tell me that all of the sides, right? Like this one here. This is a side, right? It doesn't tell me that that side is the same as this one, and this one, and this one. Can anyone see how we can know? What do you reckon, Frank?
It's a square.
I'm trying to show that it's a square though. I know it looks a lot like a square. Let me help you out a little bit. Okay. What did I name these sides again? A and B. Yeah. So if this is B here, this one's slightly longer than A. Can you see it? Right? What's this side here?
B.
This is also B, right? So what's the height of my square? There's an A here,
A plus B.
and it's B. So you just add them together. A plus B, right? You happy with that?
Yeah.
Now have a look at the bottom. Have a look at the bottom. Can you see? I've got B here. What's this guy?
A.
It's A. So what's this?
A plus B.
And you can do this all the way around the 4 sides of the quadrilateral. So you're like, they're all the same. They've all got right angles. That's a square. Okay. There's another square too. Do you see where the other square is?
Yes.
It's right there stuck in the middle, right? In fact, it's so important, I drew it as well, okay? So you can see it's off at an angle, bit of a funny angle. So it's in here. Okay, now, Pythagoras' theorem has a lot to do with this particular blue square. That's why I drew it for you, okay? I want you to think for a moment. What's the area? We've done area before. What's the area of this blue square? What do you reckon, Jerome?
C times C?
Remember, all of these 4 triangles around the edges are the same. This is C, this side here. That means this is C as well. In fact, they're all C, okay? In fact, that's so important, I'm gonna label this square, let's do it like this, C squared. Can you see that? That's the area. Now, I don't know what C is, but algebra doesn't care. It's like, well, whatever it happens to be, it's that squared. It could be like 10, which would make this 100. It could be 7, which would make this, what would that be? 49. It could be 8, which would make that 64. And no. Could be anything. That's my point. Okay, now let's just take this guy. I'm going to put C squared over here for a minute. Just hold on to him in your mind. Okay? Right, I need a little more space. Now what I'm going to do here comes the proof. That was just the setup. I'm going to just rearrange these same 4 triangles, okay? And I want you to watch the way that I do it. Do you remember back in term 1 or 2, we learned about these things called transformations. We could change shapes, we could like move them about in different ways and they stayed the same. Do you remember what the 3 transformations were? Any suggestions? Nikhil, can you give me one? Slide or translate. What's another one, Frank? Reflect or flip. And the third one was? Christian? Rotate, okay, or spin or turn, right? Now I'm going to use 2 of those. I'm going to use rotation and I'm going to use translation, that's sliding. Okay, watch. I'm going to take this guy, I'm going to rotate him around like this. Spin. So he's over here. Okay, are you happy with that? You see how I did it? Okay, I'm going to do another rotation. This one, I'm going to rotate in a similar way, anti-clockwise, around like that. No shapes have changed, they've just moved positions a little bit. Okay. Now I'm going to do my translation. I'm going to slide. I'm going to take this shape. What's this shape now that I've made?
Rectangle.
It's a rectangle. I'm going to take the whole rectangle and I'm going to move it over just a little bit. Okay, now this is my new setup. Still the same 4 triangles, but again, I've made some other shapes that you can kind of see around there, right? For starters, can you see I've made this guy over here? You see this guy? What kind of shape is that?
Square.
It's a square, again, but it doesn't just look like a square. How do you know it's a square? Christian, what do you reckon?
Because it's both sides are A.
Yeah, very good. See, I've even got this one labeled A, and because these triangles are all the same, this is also A. Okay, and there were also all those right angles I told you about before. But that's not the other square, only square. There's this one here, right? You see that? You with me? Okay. Now, what are the areas? What's the wrong one? What are the areas of these 2 squares? Well, let's do the first one first. It's A times A, which makes it A squared, right? How about this one over here? Yeah, B times B, so it's B squared. Okay, so I've got these 2 cool extra squares, but then have a look, now that I've put everything together, what is this big shape that I've made?
A square.
It's another square. In fact, it's not just any square. Isn't it the square I started with, the big one? Have a look. What's this width across the bottom? It's A plus B, right? And you can say the same thing of the height, can't you? So in other words, the 2 squares I made, the 2 big ones, were exactly the same square. Are you okay with that? Okay. Now let me just draw that square over here. It looked like this, if you recall. Something like this. There we go. Do you remember that? Okay. Here comes the finish. These 4 triangles, they started off really important, okay? But I'm going to take them away from both of the squares. There we go. That just leaves me with those bits, right? Now, these are the leftover parts, right? Take away the 4 triangles, okay? But look, I've got these 2, they were the leftover bits. In the first place, the leftover bit was this whole square. Do you agree? So therefore, what Pythagoras' theorem tells us is that all of these sides, they're related in this way. If you add these 2 gaps together, the leftover bits of the square, they're the same as those leftover bits of the square. I've just rearranged them a little bit, okay? And this, 1, 2, 3, this is what we call Pythagoras' theorem. If you've got any right-angled triangle, okay? And now I want you to open your book up again, okay? If you didn't draw your triangle with a ruler, I'd like you to draw one with a ruler. Maybe you need to borrow from a friend, okay? And what I want you to do is I want you to measure those sides. Now it's really important that the sides meet at a right angle like that. If you measure them, for example, on mine, what I did was I measured out these all of these sides, okay? I think from memory, I think this is 12.6 centimeters and 16.8 centimeters. You can work out what the last side is, the longest side. You can work it out by just measuring it, by putting a ruler on it. But you can also work it out using this relationship here. that a squared plus b squared will equal this last side here squared. In this case, it's 21. Okay, a really famous one. If you have drawn like a triangle and it's a bit messy, you can draw a new one. Make it like this. This is a very famous one. If you've got one edge that's 3 centimeters and one edge that's 4 centimeters, so long as they meet at a right angle, this last one should be 5. You can't help but make it 5. Here's why. Watch. What's 3 squared?
9.
3 squared is 9. What's 4 squared?
16.
It's 16. And if you add these two together, you get
25.
which is 5 squared, right? Very good. So you can do this with any set of triangles. Another famous one is 5 centimeters and 12 centimeters and 13. You can do the squares yourself and you can find out 25 plus 144 is equal to 169. Okay? And you can do this with any triangle you like. They don't have to be nice, neat numbers. They can be weird decimal numbers or fractions or anything. Pythagoras' theorem tells us this is always true, no matter what right angle triangle you have. Okay?